All right, guys, here is a real world problem. This is number 4. It is the third page in the slideshow. It would have been page 40 in our unit organizer, the little unit books. So, depreciation. Depreciation, the table shows the depreciation of an automobile. If you went over the vocabulary slideshow, you saw that depreciation is how much something goes down over time. You buy a new car, this particular car, how much did it cost us? So if you look at the table, years, 0 years old, the car is $33,874. Look at after 1 year. Is it still worth 30 something thousand dollars? 2 years, 3 years, 7 years? So using that context clue of what is going on the table, we should be able to figure out that depreciate means it goes down. Over time, the value of your car depreciates, it goes down. That happens with a lot of things. Houses normally appreciate. That is the opposite. Usually, if the market is good, our houses will appreciate. They will go up over time. Well, I don't think they really follow that kind of steep of a curve, but they do go up. Appreciate. All right. So we're going to make a scatter plot of our data. So if you go over here to Desmos, there's my scatter plot. It looks pretty linear, doesn't it? If I put a line, it looked linear until I threw that line in there. Does it look linear anymore? It goes through 2 of the points, a few above, few below. Let's focus on our R value here, 0.96. Okay. I have the quadratic in here again. Our quadratic, once again, it looks strong. Looks strong. It's got a 0.99 R value, pretty stinking close to 1. But once again, the context of our word problem is it's depreciating. Is our car going to reach 9 years, then all the way a sudden shoot up in value? Now, I bet if we were sitting here in class, somebody would say, oh, but Miss Jones, a classic car, an antique. Yeah, but that's way the heck down. Your car does not become an antique after 9 years. So, yes, that's true. Your car might actually go up in value eventually. But at this point, at 9 years, your car is not shooting up in value. If anything, I'm going with the linear over the quadratic when it comes to talking about this scenario. And here is our exponential. So there we go. It spot on, hits more dots than our linear does, doesn't it? It went through those two, that one pretty close up there. So this is, and look at our R2 value, 0.9961. So even if we had kept that quadratic one, this one had a better R value when you carried it out, 0.9961 versus 0.9935. Remember our R squared value? The closer it is to 1, the better of a fit our line is. So there we go. We did A, make a scatter plot of the data. I would love for you guys to take a screenshot of that and stick it in this box. B, determine whether it's linear or exponential model. Determine whether a linear or exponential model best fits the data. Write the regression equation. So, which one fit better? It was exponential. And our regression equation right here. A is 0.334219. So our equation will be y equals 3, 3, 4, 2. I'm going to round 2, 33,422. That's about the price our car is starting at. B is 0.835. So let's erase this. It's in the way. B was 0.8358. I'm going to put 0.836. And x is our exponent. There we go. That is our equation. Let's come back over here. You can type that in here. So you made your scatter plot. You determine whether it's linear exponential, and you wrote your equation in this box. Use your equation from part B to predict the value of your automobile after 10 years. So you're going to make x equal to 10. I'm going to go back to my graph. So you're going to make this equal to 10. I'm going to go ahead, since it asked me to use my equation, I'm going to type it in. 3, 3, oh, y. Oop. Oh, what did I just do? I'm going to add equation down there on the bottom. Y equals 3, 3, 4, 2, 2, parentheses, 0.836, parentheses, shift 6 gives me the exponent to the x power. That's my equation. I just pretty much regraphed my red one. And I'm going to make the x equal to 10. And look right here. $5,573. All right. I am going to do it graphically now. Add another going to add another expression. Oh, they put it up there. I'm going to make x equal 10. We've done this in class. So let's see. Let's take this one out. Oh, it's behind my head. So right there, $5,563.96. Now, why was my calculation using this equation not exact? What did we do? 33421.9, I rounded to 2. 0.836, it was 0.835863. So we did do a little bit of rounding, which did give us a little bit of a different answer when we did it algebraically versus using our graph. But still about $5,564, 5,573. Unless I entered something wrong. 33422.836. Nope. There you go. So about $5,500. So I would like you to come back over here and enter your answers in this box right here. Great job, guys. How many of you guys feel good about calculating depreciation? Yeah? Oh, the one other thing I wanted to tell you guys. So back to our B value. We keep talking about the B value. Look at this B value right here. B is less than 1 but greater than 0. If B is a fraction or a decimal, it is going to be a decay. Just keep that in mind when you see these problems, or if you got to match these problems. How do I know if it's growth or decay? If it's below 1, it's going to be decay. It's going down. It's decreasing. Now let me give you your heart and your thumbs up back. Woohoo! Good job, guys.